The name of our topic is the organic synthesis via Enolate. In the introduction, we have studied what is meant by active methylene compound. Yes, we have studied example of diethyl malonate, CH2 group when attached from both sides by electron withdrawing group. Then that compound is called active methylene compound. That group is active methylene group. Actually, in the first step, या पहिल्या स्टेप मध्ये आपण यामधला पहिला कंपाऊंड स्टडी करतोय aceto-acetic ester, that is ethyl acetoacetate. In ethyl acetoacetate, there is one ketone and second is the ester group. एका बाजूने ketone आणि दुसऱ्या बाजूने मात्र ester आहे. Okay, means there are two electron withdrawing group. We have studied preparation of acetoacetic ester by Cleveland condensation. We have studied mechanism of this reaction also, and then about the acidity of methylene hydrogen, means why that hydrogens are acidic in nature. Let us see one more point. What is meant by Keto-Enol Tatuomerism? Okay, this is our acetoacetic ester CH3, C double bond O, CH2, and from another side ester group. This active methylene compound can be converted into another form. It can be converted into another functional form. Here that one hydrogen atom, it goes to on the oxygen and इथं असणारा जो double bond आहे, that double bond goes in between that two carbon and there is the formation of another. म्हणजे इथं डबल बॉन्ड आलेला आहे आणि इथला एक हायड्रोजन इथं ऑक्सिजन कडे जातोय. And here this first form is called keto form because there is a keto group. There is a keto group. While that second form is called enol form because OH hydroxy group is attached to the double bonded carbon. In means double bonded carbon. OL means alcohol. Means here OH group is attached to the double bonded carbon. This is called enol form. Okay. Actually, both are acetoacetic ester. Both are same active methylene compound. But first is the keto form and second is the enol form. And that two structural form of acetoacetic ester interconvert into one another. They interconvert into one another. And they exist in a dynamic equilibrium. And that process is called tatuomerism. This is called Keto-Enol Tatuomerism. When two structural form, they interconvert into one another and they exist in dynamic equilibrium, then this is called tatuomerism. Here, that first form is called keto and second form is called enol. In keto form, there is a carbonyl group, there is a keto group, while in the enol form, OH group is directly attached to the double bonded carbon. Hence, it is called enol form. Okay, this is just about the Keto-Enol Tatuomerism. Actually, ethyl acetoacetate exists as an equilibrium mixture of these two functional forms. One is a keto and second is the enol. Okay, and this phenomenon in which two structural isomers spontaneously interconvert into one another and exist in dynamic equilibrium is called tatuomerism. I have already told. And the tautomer which contain carbonyl group is called keto form and which having OH group attached to the double bonded carbon is called enol form. And this concept is called Keto-Enol Tatuomerism. That tatuomerism can be exist in a small amount of, in presence of small amount of acid and base. Now let us see mechanism of this. Means how actually that keto form is converted into the enol. Now let us see, this is our keto form of acetoacetic ester. Now in presence of small amount of base. Now what happens here? We know that hydrogen atom of methylene group, it is acidic in nature, means that methylene group can easily remove that hydrogen. That OH can easily abstract that hydrogen कारण हा कंपाउंड ऍक्टिव्ह मिथिलीन कंपाउंड आहे. इट हॅव्हिंग टेंडन्सी टू लूज दॅट हायड्रोजन इझिली. म्हणून हा बेस इझिली तो हायड्रोजन घेतो. मीन्स बॉन्ड बिटवीन कार्बन अँड हायड्रोजन undergo breaking and this electron pair goes towards carbon and that carbon acquires negative charge. Here carbon acquires negative charge and we get the intermediate and this is nothing but the carbanion. This is the carbanion. This is very common state. म्हणजे कोणताही ऍक्टिव्ह मिथिलीन कंपाउंड असेल, when it comes in contact with the base, it can easily remove hydrogen and to form carbanion. Suppose this is our carbanion. Now what happens in the next step? Now this carbanion undergo delocalization. It undergo delocalization इट शो द रेझोनन्स इफेक्ट. तो रेझोनन्स इफेक्ट दाखवतो. म्हणजे या ठिकाणी काय होतं, हिअर दिस इलेक्ट्रॉन पेअर फॉर्म अ पाय बॉन्ड बिटवीन टू कार्बन. This electron pair delocalized in the ketone group. It may be delocalized in the ester group also, but suppose how it delocalized in the keto group. This electron pair form a pi bond between these two carbon. Now simultaneously that pi bond between carbon and oxygen undergo breaking, and this electron pair goes on the oxygen. Means here there is formation of pi bond. This bond undergo breaking and electron pair goes on the oxygen. We get the canonical structure. Okay, this is the resonating structure for the carbanion. Okay, and this is nothing but the enolate ion, and यालाच आपण enolate ion असं म्हणतो आहोत. Now this enolate ion takes one hydrogen from the water. There is a formation of OH group, and that OH is attached to the double bonded carbon, and this form is nothing but the enol form of ethyl aceto acetate, and thus this keto form of ethyl aceto acetate converts into corresponding enol form. म्हणजे आपण हा मेकॅनिझम स्टडी केलेला आहे. जस्ट टू स्टेप मेकॅनिझम. इन फर्स्ट स्टेप, this abstract hydrogen atom from the methylene group, we get the carbanion. This carbanion is the resonance stabilizer. It can be converted into enolate ion. This is the enolate ion. Now that enolate ion can take hydrogen, it can take proton from the water, and it converts into enol form. आणि त्याचं कन्वर्जन enol form मध्ये होतं. Okay, this is just about the mechanism. आपण mechanism स्टडी करतोय. Now let us see stability of that keto and enol form. In aqueous medium, that keto form is more stable than enol form. Its contribution is up to the 90%, while enol form is having only 10%, because this is the more stable in aqueous solution. म्हणजे aqueous medium मध्ये हा keto form more stable आहे. Okay, suppose in liquid medium, पण liquid मध्ये काय होतं, liquid ethyl acetate असेल तर काय होतं, in that case this keto form having only 25% contribution, while enol form having 75% contribution. So why in liquid state that enol is more stable? Liquid state मध्ये enol हा more stable आहे आणि keto मात्र कमी stable का आहे? This is because in enol form there is a hydrogen bonding. म्हणजे इथं जो OH ग्रुप आहे, OH group which is attached to the double bonded carbon. Okay, तर इथं जो हायड्रोजन असतो, that hydrogen having partial positive charge, because the bond between oxygen and hydrogen, this bond is a polar. OH group हा polar आहे. Oxygen having partial negative charge, hydrogen having partial positive charge. This is the polar. Okay, तर ester group मधला जो C double bond O group आहे, that oxygen having partial negative charge, they having electrostatic attraction, आणि यालाच आपण हायड्रोजन बॉन्डिंग असं म्हणतो. दिस इज द हायड्रोजन बॉन्ड, अँड दिस इज द इंटरमॉलिक्युलर हायड्रोजन बॉन्ड, and due to that intermolecular hydrogen bond there is a formation of 6-membered ring. यामध्ये 6-membered ring तयार होते, and therefore it is more stable. आणि म्हणून comparatively that enol form जो आहे in liquid state it is more stable. But generally in aqueous medium, आपण generally chemical reactions we are carrying out in aqueous medium or polar solvent, पण त्यामध्ये मात्र keto form is more stable than enol form. हे लक्षात ठेवा. This is just about the stability of that keto as well as enol form. Okay, now we are just discussing about the Keto-Enol Tatuomerism. We have studied in the introduction what is meant by keto and enol tatuomerism. आपण या ethyl aceto acetateचं keto-enol tatuomerism पाहिलं. Then we also studied base catalyzer mechanism for keto-enol tatuomerism, and also about the comparative stability of keto and enol form in aqueous medium as well as in its liquid state. Okay, this is the keto-enol tatuomerism.